All right, looks like everyone's in their seat, ready to go. So thanks for coming out. You notice here that I'm bringing up. A few things I wanted to say just before we hand it over to Marconi. So we started our Toronto Scala Night School series of events. We have five sessions planned out. It started last Thursday, and they're going to go roughly every 2 weeks. PagerDuty is hosting it for us, and we're expecting a crowd of about 20 to 35 people, and it's geared towards just new users of Scala with no previous experience. So I appreciate that not everybody in the group is RSVP, because that would have muscled in all the new people. And the smaller the events are, the more feedback and interaction we get during them. So it's been good so far, and I appreciate everyone who's reached out to help out as a mentor or just with the material. So thanks. And thanks to Catherine for doing the first event on Thursday. It was a great hit. Our next session is next week, and we'll see the invite for that soon. I also wanted to mention our partnership at the end of the month. There's an event with Dean Wamper. So Dean Wamper from TypeSafe is coming to Toronto. And we're partnering up with the Spark Meetup to have two events. The first one is at Spark Meetup. It's going to be more Spark focused, obviously. And then the Scala meetup is the day after, and it'll be more about the internals of Spark and how it's implemented in Scala. Both events are at Loyalty One, so I encourage you to RSVP both. It's February 24th and 25th, I believe. And that's it. I'm just going to let Adam say a few things. This clean stuff, super great. So I think everybody found the pizza. I over-ordered. Please take them home or eat as much as you want. I won't tell anybody. Bathrooms, men's is right there. Women's is right there. Exits, obviously the front door, one at the back, another one at the back. Run screaming, trying to trample anybody. And there's a lovely alley to sit outside in. It's beautiful weather. That's really it. One normal item that we're getting out of the way is we're hiring, so I'm shamelessly promoting ATM Lab. Hello, there you go. This thing has auto sensing, and I don't know how to turn this feature off. We're just go to ktmlabs.com. That's all I'll say. We're hiring data engineers and machine learning engineers still. So that whole where you're sitting, I want to fill out with people. So we're growing, and that's awesome. Let's talk about a little bit more meetups that are happening here, just real quick. So we had our first stub in a while. There'll be another one next month. We're now hosting Neurotech. We're hosting a whole bunch of new Toronto Tech meetups. So some of you may be interested. If you have ideas for meetups, I wouldn't mind hearing about them. They're genuine, like startup driven. It's not funded by IBM. They're just looking for another home. It's stuff that's genuinely community driven. We would like hosting. And furthermore, I'm really looking forward to the Demonter visit. That sounds awesome. Thanks, and thank you. Thank you, Adam. So let me turn it over to Marconi. I first met Marconi last year at Scala Up North. I think he's going to tell you a little bit about the next event too. It was the first Scala conference in Toronto, or in Canada rather. Marconi is an itinerant speaker at a lot of Scala conferences around the world. He's been doing it for a few years, so we're really privileged to have him here tonight. So let me turn it over to Marconi.
Thank you. Okay, let me start the Scala REPL here. So while it starts, thank you everyone for coming. It's really nice to see you all here. And I would like also to thank Catherine and Sean for organizing this event and keep it on schedule. I know they are doing a pretty good job in trying to keep this meetup alive. Okay. So this is the Scholar repo, no smoke and mirrors here. My name is Marconi. I work for Originate, and I'm going to be your entertainment for tonight. So Sean asked me to present here back in December, and actually I was asked to visit the client, to spend a week at the client, so I had to cancel my presentation at the last minute. And as punishment, he asked me to do 2 talks tonight. But I'm not sure who's being punished here, if me or you. And he told me that he's interested in trying to attract more beginners to Scala, people who are just learning about the language. So he asked me if I could do a more, entry-level talk. So I said, nice, I have an entry-level talk that I can give. The second talk I'm going to give tonight, it's a little bit more intermediate level, but I like it, even for people who are new to Scala, because it shows you just how much power you can achieve when you really leverage, the features that a language with a strong static typing like Scala has to offer you. So I think you're going to benefit a lot from that too. So this first talk is called Idiomatic Scala, Your Options Do Not Match. It was presented previously at LambdaConf in Boulder, Colorado, and just a few weeks ago in London at the Scala Exchange, both last year. But before I get started, shameless plug here, I have no shame. I'm not the kind of person to refuse to waste a good opportunity. So I am one of the organizers of Scala Up North. It is the only Scala conference in Canada. Last year we had an event here in Toronto in September. I see many faces here that were there. And it was awesome. I think it did really great. And we're going to do it again. Again, late September, probably in Montreal. It's where we are trying to take the conference. We want to do like Scala or Scala days that every year it's a different city. So you people don't get bored of me so easily. Details to follow. If you want to see the videos from last year, they are available online for free at scalaupnorth.com. And if you want to follow us for updates, go to Twitter/scalaupnorth. And as soon as we know we have a date and a venue, we're going to announce and start opening the call for proposals. So if you have an interesting topic that you want to talk about, don't be shy. If I can do it, anyone can do it. We're going to love to hear you talking at the conference. Okay, so raise your hand who has never seen code similar to this. Okay. And pay attention, I'm using return and semicolons because this may be JavaScript, this may be Java, but no one would write Scala with return and semicolons, right? If you have someone in your team writing Scala with return and semicolons, you have much deeper problems, I'm afraid. So yeah, we see that, this is something that a beginner probably would write. And it works, but the problem with this code is, someone more that has better knowledge would just return some Boolean. Now, raise your hand who has seen even written code like this. Some option match, case sum, case none. Don't be shy, people. I know. Okay, so I really don't like this pattern, this code pattern, because to me it feels too literal, too unrefined, unsophisticated. It's not a high level and high enough level of abstraction here. It's not declarative enough. It feels procedural, like you're telling the machine step by step what it should do. In a sense, to me, it reads and feels like if some option equals some A, foo A, else, if some option equals none, bar. So it's even worse than the if true else, because you have an else if on the second clause. But you come to me and say, but Marconi, pattern matching is functional. Functional language, they are known for having pattern matching. So how come you're saying that we should not use pattern matching? Yes, I do agree. Pattern match is functional. But higher order functions, they are functional. They are the functionless thing you can use, a higher order function. So pattern matching on option, it's almost never necessary. And really, I don't know why I wrote almost here, because it's never necessary. Okay. There are cleaner and more expressive ways, better ways for you to get to the same result without pattern matching. Okay. So if you don't believe me, I'm going to refer you to the source. This is the Scala doc for the option. And this is what it tells us. The most idiomatic way to use a Scala option is to treat it as a collection or monad and use map, flat map, filter, or for each, the higher order functions. A less idiomatic way to use Scala options is via pattern matching. So it's not me who is saying it, okay? I'm just being paid to say it. Of the form, some option match case, non-case sum, can be written as some option map foo, get or else bar. Gives you the same results. It's a single line. It's very expressive, very easy to read, to write, to understand. And that's it. The talk is over. No, not really. Okay, we can do better than that. Since Scala 210, we have an alternative that it's fold. So you have some option, fold, bar, and foo. So here is something that you have to be aware that the word it's a little counterintuitive. It's reversed because it's none first, some later, but it does the same job. It does it better actually, because folder has better type safety than using pattern matching or map, get, or else. So I'm going to give an example here. I have an option, and I'm going to use pattern match, and you can see that on one branch, I have an integer. On the second branch, I have a string. Maybe I did something wrong. I don't know, copy and paste. And it's the same for map, get, or else. I have a map on an integer, but then I get or else on a string. So if I run this code, you may think that it should not compile, but it compiles, run, and returns normally. So now A and B, they are of type any, and they have a value 2, an integer 2. On the other hand, if I try to use fold and I mix the strings and integers, when I run this, I get a type mismatch. My code does not compile. So fold, it's a much better alternative to map, get, or else, and pattern matching. And that's it. So the talk now is over. No, not really. We can still do a lot better than fold. It's not the end of the story. Are you convinced so far? Well, I don't need to continue. I showed you two alternatives. One is better, the other one is the best. But we still have more to see here. So we have dozens of higher order functions. I'm not going to show you all of them, that can be used to express some specific transformations. So they are not general case. Map, get, or else, and fold, they can be used for anything. Those here are for a specific particular case, but they are more expressive for those particular cases. So they don't apply everywhere, but when they do apply, they're going to be better than even fold. Okay. For instance, if I have fold, false, true, I can replace that with is defined. Okay, option is defined. So let's see some examples here for real. So we're gonna play a game. Okay, you're gonna do the talk. I'm just gonna say if you're right or wrong. Just a few definitions here. I just have a type here, not to repeat it everywhere. I have three variables: an option A, an option empty string, and none, all of the same type. And I have two functions. One is a predicate. So if you're not familiar, predicate is a function that returns a Boolean. have this nice name. And the other one is just a transformation. So one will test if the string is empty, and the other will convert the string to uppercase. Okay, I have everything defined here. And you do not need to worry about this. It's just a helper function that I created to show us the results. What it's going to do, it's going to take two functions from option to anything, and we'll run those functions against the three values that I had, A, empty, and none, and then compare if the results are the same. If the results are not the same, it's going to complain to us. So just to give an example here, pretty trivial. I have two functions, and I'm going to run them. And I see that when I pass a sum A to both functions, they return the same result. They return a capital letter A. When I pass the empty string, the results are the same. But when I pass none, they don't give me back the same result. So it's just to verify that I'm not lying to you. Whatever I'm saying, it's true. The Scala compiler is here to not allow me to trick you. First one, if I have a pattern match that is sum A, I'm going to return a sum FA. And if I have a none, I'm just going to return a none. What function is that? What can I use to replace this pattern match? Okay, map. This one was easy. You know, it's just to get yours. Oh, sorry about that. We didn't see the results. So there it is. Both functions return the same results, my pattern match and map. So now I have sum A returns A. In case none, I'm going to return B, which is the default case. Get or else. So I have a get or else B, and it has the same result as that one. So couldn't be easier. It's going to get harder. Now I have sum A returns FA, case none returns B. No, single function, just one. Okay, so someone paid attention to what I said 5 minutes ago. That's full, okay? Gives us the same result.
I don't know, can you spend like half minute to elaborate like how it works? Like you pass just parameter, how full makes this matrix that it works?
Okay, you asked me after the presentation. Let's see the next one. So sum A false, case none true. Is empty. Okay. Now the reverse. Sum true, none false. Is defined. Also not empty. We have an alias for that. Okay. Next one. Sum A 1, non-zero. Size. Congratulations. Sum A option B. Or else A no. Or no, exactly. Yeah, that was, I just said the answer. Yeah, so let's stop here for a second. What the hell am I going to use that? Because the reason we use options is to avoid no, so why do I want to go back to no? And the answer is pretty simple, because you're going to call a Java API that knows nothing about option. So if they are expecting no, please don't pass a no to a Java function that does expect a no. So this is how you do it. It's very simple, option or no, and you're back into Java land. Case sum A if PA. So now my predicate has to match as well. Sum A case anything else. So case none, case sum A, if not PA, none. Filter, okay. If not PA, it's the same as before, but now it's the reverse. Filter not. Yes. Case on A equals the empty string.
Exists.
Contains. Okay. So I'm going to see if my function contains that string, if my option contains that string. And now it's something that you have to pay a little attention here because it's easy to get confused. This is the option itself contains that string. It's not whatever the option contains that string. So if I try option banana contains A, the answer is false. No, it does not. What if I want to check if the option banana contains A? How do I do it? Who knows? In a single step. Okay, so you're going to learn. Case A, case on A, PA, case non-false. Doesn't ring a bell? Okay, it exists. Okay, so this is how I verify if my option banana contains A. So I pass a function. So option banana exists, contains A, and yes, the answer is true. Some A, P, A, non. Oh, whoa, what's that? For all. Yeah, so that one, it's a funny one because it's surprising, you know, if you have a none, it returns true. And actually, it's very useful, you know, once you learn about it and you realize that it makes sense, you know, mathematically it makes sense, even though it may not be intuitive to you. And this is very useful. So let's say you have, you're sending email, you know, you're spamming people. And then they ask, well, let's put a column out on our table because people are complaining about our emails. So your column may not have a value because the column was not there since the beginning of time. And people may opt in or opt out. And you know, if they have not opt out, if they have not, if they say nothing about it, you're going to spam them. So this is for when you have something like it's opt out. You know, unless someone told me they don't want it, I'm going to keep sending them. Can be really useful. Some A if PA 1, otherwise 0. So this is similar to size, but we have a predicate here. Count, congratulations. Count. That is also very useful when you learn about it. Now we have some A, print line A, case none, does nothing, just returns units for each. And yes, I printed something there. There's a blank line. Oh, this one is interesting. I have some A right A, none left B. To right. And this is one that you have to pay a little attention because it's tricky because you say to right B, but the B will be the left, not the right. So I think this one is not properly named. It should be to right or else B. It would make a lot more sense. But it is what it is. We cannot change that. We have the converse. It's to left, of course. Last one. Yes, to check. Oh, not last one. This one, of course, it's to set. I mean, should be obvious by now. So you can convert an option to a set. 4 comprehensions, okay? So I showed you the higher order function, but we still have other options that we can use instead of just the pattern matching. Now, we should not forget that options is a monad. It's the made monad. And so we can use them in 4 comprehensions. So I have here a person has a name, and a mother. I mean, everyone has a mother, but we may not know who someone's mother is. So it doesn't mean that you don't have a mother, just that we don't know who your mother is. And then I have two methods, grandmother, great-grandmother. And really, I was not very creative here, but I just wanted to show that you can ask it as deep as you want. And let's see this in action. So I have a few people here. Who knows Bartolomeo Jojo? Yeah, it's Bart Simpson. So we have people here. Let's run this code. So what we have, when I ask for Bart grandmother, it's going to return for me Jackie. Oh, I cannot scroll back. Oh, sorry. Because it's his mother. But if I try something that ends in a non, it's going to stop there. We will not try to ask for the non-mother. So just to show that it shortcuts. Okay, so this has been pretty boring so far. You know, just stupid thing. Not very interesting. Why did I waste my time telling you such a basic stuff? And the point is that this is not just a matter of personal preference. You know, it's not just a matter of coding style. If you do pattern match on an option and you work with me, this is never going to pass my code review. It's not because I am picky, but I am. It's because, you know, we have to remember that option is a collection. It's not just a monad, it's a collection, you know, a collection of at most one element. And when you start to think of the option as a collection of at most one element, a lot of things start to make sense and become simpler for us. Okay? It shares the same API that other Scala collections have. So the Scala collection API is very nice because they have a hierarchy of traits and many, many collections, even though they're very distinct, they conform to the same API. And option is one of those collections that conform to the same API. So let me show you here how this is useful. Let's say that I have a case class employee, and again, bad name. The employee is not bad. The class is bad. Okay? So this is not a class bad employee. It's a bad class employee. I have a name and a company, option string. So what that means is that a person may or may not be working for a company right now. Okay? May or may not be employed. So I have a method is employed, and I'm using pattern match there to see if the person is employed. And I want to see if the person works for a company. Again, I'm using pattern match for that. And so I'm going to create an employee, Joe, that works for Acme. And I'm going to ask if Joe is employed and if he works for Acme. And of course, the answer is true. So this is the version using pattern matching. Now, this is the version using higher order functions. So if you pay attention, you're going to see that I went from almost 10 lines of code to 2. That's not all. And I mean, same result, of course. That's not all. Now it's when it gets better, and now it's when I hope to convince you not to use pattern match ever again. You know, the economy is bad. Our dollar is worth pennies, quite literally. So people have to work for more than one company now. They have to work 2 or 3 jobs to make ends meet. So now we have my class, good employee, that used to be an option. I need to convert it to a sequence. And can you spot the difference? I'm going to bring the other one here. This is with option. Now with the sequence, I changed a single keyword. I didn't have to change my code at all, because the same methods that work for option, they work for sequence. If I run it here, I'm going to get the same results again. So can you imagine how much work we can save if you have several methods with lots of chain operations? You just need to change the type. You do not need to change your code. It's a lot easier. If we go back If we go back to the bad employee, you would have to rewrite everything here. And if you stick to pattern matching, doing pattern match on the sequence, you would have probably to recurse on the function. It would be a mess. But if you are using this, the higher order functions, you do nothing, and call it a day. That for me is the main reason why I will reject any code that pattern match on an option. And of course, what I said here.
Yeah, I think you may be covering that, but I think one of the strengths is the notion of having an abstract data type is sort of problem with pattern matching is you have an arbitrary data type which is great, but it reinforces things on the constructor. If you ever need to change it, if you ever want to extend it, that becomes hard. Having things in terms of functions and perhaps having things, views or things like that you can have multiple interpretations of it is much more powerful technique because you can change things without touching the entire code base without having to make sweeping changes.
Yeah, exactly. Thank you. So what I said here applies to more than just option. Okay? Abusing pattern matching can be considered a code smash. Pattern match is not always the most readable or concise construct. Do not pattern match on Boolean. Don't laugh, it's true. I've seen people doing that, okay? They have case true, case false. Don't do that, use something else, okay? Do not pattern match on a single value followed by a default case. If case 0, case underscore, use if or else again. Come on, people. If and else is in Scala for a reason, pattern match is not a substitute. And for most data structures like sequence strings, use methods like isEmpty, had option, tail. So those of you who were at Scala Up North and saw my talk on one-liners, this is something that I spent quite a lot of time there. It's showing you all the power that you have. That in Scala, a Java array is a Scala sequence, so you can do everything that you can do with list and sequence. You can do with a Java array. A string in Scala is a sequence of characters. It's a collection of characters, so you can use the same methods there. You can call head option on any string. That's awesome. Don't use substring. Use head option, and I can show you here. That's the nice thing about using the much better than use a substring and then trying to catch an exception. So all those functions they work with things that normally you would not expect. If you're using enumeration, use with name. Do not pattern match just to convert a string to enumeration. Okay, so that was my first talk. I hope it was not too boring because you know everything about Scala already. But it's a nice thing to remind us. These slides are on my GitHub. I mean, they are not there. They will be there as soon as I'm done here tonight. You can go to blog.originate. I wrote a blog post there and talking about exactly about this, and I'm going to much deeper detail, and I give you a lot more context over there in this blog. Hey, if you like this talk, you may also be interested in my elegant and powerful Scala one-liner. Many of you already saw it live last year. Okay, and yes, of course, this presentation, there's always someone who asks me, this is the Scala REPL, no smoke and mirrors here. It's a tool that I created, and I'm going to tell you a little bit more about it on the next presentation. And that's it. Thank you. And do we have questions? No? Okay, great. 10 minutes, 5 minutes?
Yeah, 5 minutes.
5 minutes.
Keep going.
And then we come.
Yeah.
I think we lost the screen sharing. I didn't want to interrupt you, but
I'm going to have a police van. But Marconi will come to our sessions. You know why? Yeah, because it's like bans that you can't enter like 2 kilometers. The perimeter because it's scary for the beginners. It's fine, alright. Not only if else, but options. It's fine. Don't kill anyone.
You get to learn options.
Yeah.
We've never seen an option.
So Wi-Fi is on, the Hangouts is on.
I think screen sharing turned off somehow.
In the middle?
When I
That was never on. I didn't want to interrupt.
well, the slides were there at the time.
The slides were up, yeah. It's just the.
So how does it work? Well, I don't know. Yes, I'm connected here. So when did you look? Because if I cannot go full screen, then was it when?
Maybe try sharing it again, and we'll just.
Yeah, let's see.
I'll see if I can see it on my screen. What is that? What is that? As a window? Or
It's a terminal, yeah. The background is transparent because it's meant to be full screen. Do you see my?
I see the terminal now.
Yeah.
It's a little funky.
Yeah. Okay.
Okay. We'll
Now
try that.
let me put it full screen. And
Oh, yeah. That's what happened. That's okay. It's not a big deal. Not a big deal at all. I'll just kill this.
Yeah, especially if you have slides.